This chapter also covers percent problems. Now, I remember being a kid and having those problems. What percent of this is that? Blank is blank percent of what number? Blank percent of blank is what number? Etc., etc., etc. Those types of problems. And I remember clearly getting every single one of them wrong. Yep, when I was supposed to multiply, I divided. When I was supposed to divide, I multiplied. When I was supposed to divide, maybe I would divide the wrong direction. I got them wrong all the time. And then I had a teacher that taught me the box. Now this particular chapter is not focused a lot on percent problems. However, in your future workplace, there's a good chance that you're going to have to deal with percent problems. And so I want to go over this shortcut that I learned using what I just simply call the box. Okay? And this is what happened. My teacher simply said, organize a little box. I think it kind of looks like a window because you put the little panes in, or a present. Or here are my curtains hanging in my window. Makes me happy. Okay, anyway, in the lower left-hand box, you will always put the number 100. Above that is always the percent. And then if you really were careful in reading the problems, there was always this is and this of type of number. Well, the is number goes on top, and the of number goes underneath it. It's alphabetical. Okay. That's the simple little setup of the box. Okay. That's where everything goes. Here are some neat things about the box. The percent, because it's over this 100, you do not need to convert the percent into the decimal. Now, if you really know anything about percents, if I tell you 25%, the number that's collected from the data is not the number 25. It's the number 0.25. But we don't understand decimals that much. So if I say, oh, 0.25 people agreed with blah, blah, blah in this poll, we would be confused. So what we do is we make these numbers out of 100. That's what percent means. Per means divide, cent means 100. So instead of saying 0.25 people, we would say 25%, which means 25 out of every 100 people agreed with blah, blah, blah in the poll. So percents aren't actual numbers, they're representing decimals that we're too scared of to deal with. And so we make it out of 100. It also helps when we're polling different numbers of people. Maybe one study is asked 1,000 people, maybe another study asked 50,000 people. Well, you can't go by the number of agrees with that question in the poll because your sample sizes are too different. Anyway, this is how the box works. You know that the questions are always as I stated up here. It's always this, blah, blah, what percent of this is that, blah, blah, blah. That's where the percent is and of come from. So if I give you the example that says, what percent of 180 is 36? Okay. In order to simplify the box, I have to translate my sentence. This is the order that I translate the sentence. The first thing I always look for is the percent symbol, or the word percent. It's the easiest to identify. So in this problem, there is no percent symbol by either my numbers, so my numbers are not percents. Here's the word percent, and what's right in front of that? Oh, the word what, meaning I don't know. So that's what I'm solving for in this problem. It's asking for a percent. So I don't know the number that's above the 100 in my percent box. So that's when we replace it with our favorite letter, X. Then the second thing I look for is the word of. Of is what we call a preposition. it leads off a prepositional phrase, part of the sentence that just gives us more oomph to it. A prepositional phrase has a noun. Numbers are nouns. So right after the word of would be the number to represent the of. Why do I do that second? Well, look at this problem. I have a 36 after the is, and I have a 180 before the is. I have numbers all around here. How do I know which one is going to be used? That's why I don't go to is next. I go to of. Here's my preposition. Right after that is the phrase, and it stops before the verb is. So here's my of, here's the of number. So in my of box down here, I put the number 180. Finally, I look for the is. And any number that's either before or after the is going to be my is number that hasn't been used yet. Here's my is, here's the only number I haven't used yet, so that goes in my is box. That's how you set up the box. Now, how do you solve the box? Gets even easier yet. The box has 4 spots. 3 of those spots have numbers in it. 1 does not. Since there's 4 spots here, we have 2 diagonals. Here's a diagonal, here's the other diagonal. You locate the diagonal that has 2 numbers. Here it is. Those 2 numbers you multiply together. And then you divide by the 3rd number. And that is equal to your x. For those of you who are familiar with proportions, you're just setting up a proportion. Those of you who like those types of problems, this is cross multiply and divide. Now you can simplify this a couple different ways. You can get out your handy dandy, or I notice that, gee, I have a number up here that ends in a 0 and a number down here that ends in a 0, so I can cancel those out. Ooh, 18 goes into 36, 18 goes into 18 once, 18 goes into 36 2 times. I'm left with 10 times 2, so x is equal to 20. Now x represented a percent. You need to put the percent symbol, because remember, that's not really the number 20, it's 0.20. So your answer of what percent of 180 is 36? It's 20%. Ooh, that was kind of fun, wasn't it? Let's see what else we have that's similar. How about 45 is 30% of what number? Once again, it's already set up in that nice little fashion, so I'm going to make my little box. No, you probably won't be able to make the cute little box in the equation editor, but you can set up a proportion or a fraction, and I'll show you that in just a minute after we have this one set up. Once again, the first thing I'm going to look for is the percent. Here it is. There's a cute little percent symbol and a number by it. So I fill that in. Always above the 100, the number just as I see it. The second thing I look for is my preposition of. Here it is. It always has a noun afterwards, so that's what I'm looking for. Oh, all the way until it ends. Of what number? Once again, there's that question word meaning, I don't know. So my of is what I'm solving for this time. That one has my variable in it. And last but not least, I look for the is. Here's is. There's a number right before it. It's the only number I haven't used yet, so that goes in my is box. And then to solve, we find the diagonal that has 2 numbers. We multiply them, and then divide by your 3rd number. Well, let's see. Once again, I think we can do some reducing here. Ends in a 0, ends in a 0. 3 goes into 3 once. 3 goes into 45 15 times. We're left with 10 times 15, so x is equal to 150. It's not a percent because we're solving for the of. So if it was $45 is 30% of what number? It'd be of $150. Now, Those are the basic types of percent problems. What's going to happen though is occasionally they're going to ask for something like a percent of increase or a percent of decrease problem. Now this is a little bit more in depth and a little bit more difficult, but still not overly. We just have to think about the numbers. If they ask for a percent of increase, and like I said, perhaps they won't in this course, but in your future jobs, there's a good chance that you're going to have to take some sort of employee intelligence test. And they love to put percent problems, and they love to put work principle problems on those types of tests. So that's why I'm going through it. Percent of increase. An example of a percent of increase problem would be, say we have a population question. Say the population of Green Bay in the 90s, I remember the sign used to always say this at least, I do believe it was 97,477. And then let's say the population in Green Bay today, according to the signs that I pass all the time, is 102,313. You can tell that our population increased from the 90s to what it is today, or at least the last time that they updated that census sign. Now, if I want to find the percent of increase, the key thing that I need to remember in this problem is that I don't know how many people it increased by. So I can't find the percent that's attached to how much it increased by until I find out the amount of increase. How many more people are there living in Green Bay today than there were in the 90s? In order to find that, we have to subtract. So the first thing we're going to do is we're going to take today's population and we're going to subtract the old population to find out how many people it increased by. And if my math is correct, and feel free to check it out, see if I did that correctly quickly, is 4,836 people. So now what happens is we want to change that into a percent. We can actually go back to the box at this time. Okay? Box at this time, we need to realize, see, I'm at the edge of one piece of paper. We're still having the 100 down here. We're trying to find the percent, so that's our unknown up here. Now, what's the is and what's the of? The of amount is always your original amount. This is before an increase or a decrease. So even though you think that you're going to use today's population of the 102,000, you're not. You're going to use the 97,000 because we're increasing from there. Okay, so in this problem, this is going to be the 97,477. In the is box is the amount that the increase or the decrease is. That's what we came up with here. How many people moved in, that goes in here. The amount of the in, or if we have a decrease, goes there. In this case, it's an increase. So the 4836 goes in that box. And now that we have the box set up, we can do the same math that we've done before. Find the diagonal with two numbers and multiply them. And then divide by your third number. This gives you the percent. This translates the number of people that added on and turns it into the percent of increase. You can do that math to find your percent of increase. Once again, that works for percent of increase or percent of decrease problems. You have to subtract first to find out the amount that was actually increased or decreased. And then in your of box, you always have the original amount before there was an increase or a decrease. What number did you start with? That goes in your of box. Hope this helps.